Alright, so today we're going to be doing a review of fractions. Our objective is to select the correct comparison symbol, greater than, less than, or equal to, when we compare two fractions. Let's look at the vocabulary terms. You should remember that the numerator is the top number in a fraction. Denominator is the bottom number in a fraction. The bottom number is the total number of pieces. Possible pieces, and the numerator is how many pieces we have. All right, you know greater than, less than, the mouth opens to the larger number. Equal to or equivalent. To compose is to put together. You compose music, you're putting together notes. To compose fractions, we're putting them together, combining them. Decompose means to take apart. So when something decomposes, what happens to it? Right, it falls apart. So we are going to be taking apart fractions to be able to compare them. That's called decompose. All right, a proper fraction is a fraction that is less than 1 and the numerator is less than the denominator. So for example, 3/5. That is a proper fraction. An improper fraction is a fraction that's greater than 1 with the numerator greater than the denominator. So for instance, if I had 9/5, that would be improper. 9/5 is equivalent to what mixed fraction? Remember, fractions are numbers. Okay, so if I have 9/5, 1, 2, 3, 4, 5, 6, 7/5, 8/5, 9/5. So if I had 9/5, that's the same as saying I have 1 whole, right? 5/5 equals 1 whole. If I add these all up inside my circle here, I have 5/5. And I also have 1, 2, 3, 4/5. Okay? Remember that the fraction bar means division. What I'm saying right here is this. 5 divided by 5, and that equals 1. Correct. Any number divided by itself is 1. So if I have the numerator and the denominator that are the same, all that means is 1 whole. So my 9/5 is equivalent to or equal to 1 4/5. Now you remember that we can use models to compare fractions. There are several different models. Mostly what we used were the fraction strips, also called fraction bars, or number lines. And we use benchmark numbers. So benchmark fractions are 0, 1/2, 1 whole, and we use those to round, if you recall. So how do we compare fractions? Well, first of all, if they have the same denominator, then they have the same number of equal pieces, then we just compare the numerators. Do you have more pieces? Like say, for instance, this one is 1/4 and 3/4. Well, which one is greater? Well, obviously 3/4. If I have 3/4, that's going to be greater than having 1/4, right? So this works when your denominator is the same and you're working with the same number of pieces of something and the same size pieces. All right, but what do you do when the numerator is the same and the denominators are different? Okay, well, think about it. If I have fourths are greater than eighths in size, right? They're twice the size of eighths. So you see that eighths are half of the size of fourths. Or you could say fourths are twice the size of eighths. So if I'm comparing 3/4 with 3/8, obviously 3/4 is larger than 3/8. So the mouth of the alligator is going to open towards the 3/4. 3/4 is greater than 3/8. All right, so now what do we do if we can't compare those fractions so easily? Like say that the denominators are not the same. Well, you have to make them the same sometimes, and the way that you do that is by finding the common denominator. So you can list your multiples of each of them out until you find one that matches. So for instance, if I'm comparing 3/8 and 5/12, I would list my multiples of 8, 8, 16, 24. I would list my multiples of 12, 12, 24. Oh, I have a common multiple or common denominator. So what I can do is I can say that 3/8 equals a certain number of 24ths. Well, to get from this 8 to this 24, what I really did was 8 times 3. Or I can do 8 times 3/3, which is just the same as saying what? What's 3 divided by 3? Remember, this fraction bar means this. Right, 3 divided by 3 is 1. So what I'm really doing is just multiplying my fraction times 1. Remember, any number times 1 is itself. It's just that number one time. So if 3/8 times 1 is 3/8, we all agree that's true, right? Then I can just multiply any number on top of itself by my fraction to get an equivalent fraction, because any number divided by itself is 1. So if I do it on bottom, I have to do it on top, right? So 8 times 3 is 24, and 3 times 3 is 9. Oh, my marker's running out. Hold on. Get another marker. All right, so we have our equivalent fraction here, 9/24, okay, and we are comparing it to 5/12. So I have to do the same thing over here. I'm going to do 5/12 times 1 to find an equivalent fraction. So I'm going to be multiplying by 2 halves in order to get the denominator to be the same or common. 12 times 2 is 24. 5 times 2 is 10. So my equivalent fraction for 5/12 is 10/24. And that is larger than my equivalent fraction for 3/8. 3/8 is equivalent to 9/24. And 10 pieces is more than 9 pieces. All right, so let's take a moment and create 2 equivalent fractions and compare them. Okay, so we can think about, what did we say earlier? Let's do 1/2 and 4/8. 1/2 is equal to 4/8. All right, it's also equal to, let's see, 2/4, correct? These are all equivalent fractions. 1/2 equals 4/8, which equals 2/4. Also could equal 3/6. It could equal 5/10. 5 out of 10 is half of 10. Can you think of one more? Yeah, how about 6/12? 6 is half of 12, just like 1 is half of 2. We could even keep going, couldn't we? We could do 8/16 if we wanted to. Okay, let me show you another trick. For equivalent fractions, you can use a multiplication chart. So if we look at the 1 with the 2 under it, the 1 times 1 is 1, and 2 times 2 is 2. That looks like 1/2, correct? Guess what? Right next door we have 2/4. And next to that we have 3/6. Next door 4/8, 5/10, 6/12, 7/14, 8/16, and so on and so on. Those are all equal to 1/2, all the way down. And you can keep doing that. You can say 2/3 is equal to 4/6, which is equal to 6/9, which is equal to 8/12, which is equal to 10/15. Okay, 3/4. There's your equivalent fractions to 3/4. 6/8, 9/12, 12/16, 15/20, and so on. All right. A nice little trick there with the multiplication chart, huh? All right, so let's go ahead and review. What is the top number in the fraction? What's it called? The numerator. Good job. And what's the bottom number of the fraction? Good job, the denominator. All right, and what does it mean to compose a fraction? That means that we are going to, put it together. And to decompose, that's the opposite. What does that mean? Right, it's the opposite. You're taking it apart. Good. All right, tell me one way that we can compare fractions. All right, we can use the multiplication chart we just did. Or what can we do? We can find the common denominator. Okay. We can also multiply a fraction by the number 1, or, for instance, 2/2 or 3/3 or whatever. That is all equivalent to 1. All right, good job, everyone. We got this. Your turn to practice by yourself.